Welcome to Smart Notebook Math Tools. What's new to Smart Notebook? The following math tools will come standard with Smart Notebook. You don't have to purchase these. Added to Smart Notebook is better functionality with the ruler, protractor, compass, geodryac, and measurement instrument from Europe. You can create arcs, a perfect circle, a perfect square, and a variety of triangles. First, looking at the measurement tools. On the secondary toolbar, you'll see a measurement tool icon. And if you click on that, you will see displayed the icons for a ruler, protractor, geodryac, and compass. The first measurement tool we'll look at is the ruler. And if you look at the secondary toolbar and click on the ruler, you will now see displayed a ruler with a dark shaded region in the middle. Holding that, you can move the ruler anywhere into the workspace. You can resize the ruler without losing scale. Click on the end of the ruler, and now you'll see appear an arrow for a drop-down menu and a little circle on the bottom right. In between that, you will see an arrow going left and right. If you hold that arrow and move left or right, you can resize the ruler. To trace along the edge of the ruler, use one of the pens and draw a line as you move along the ruler. You can toggle between metric and empirical units. On the top is displayed this centimeters, and on the bottom inches. And if you click on the up and down arrow in green, you will now have the empirical units on the top and the metric units on the bottom. Re-clicking on that up-down arrow in green will reverse that operation and default back to centimeters along the top. By holding the numbers and rotating, you will see the angle displayed, and notice that the angle stays vertical for better viewing. Finally, we can change the scale of the ruler by holding the little circle on the bottom right and drawing in and out to rescale the ruler. Next, we'll look at some of these functions in our examples. But before that, let's look at what has been changed from the older version of Notebook. In the older version, you could find a ruler in a gallery, but it took at least 4 steps before you could draw a ruler onto the workspace. You had to look for 2 different rulers if you wanted to use metric units or empirical units. Lengthening the ruler changed the scale, which could prove problematic, and using a pivot point was not how we would naturally interact with the ruler. In the newer version, you could see how easy it was in 2 steps to draw a ruler onto the workspace. The one ruler had both metric and empirical units on opposite edges, and lengthening the ruler did not change the scale, which is a great feature to have. The ruler acts on a pivot point at 0 length. Now let's use a ruler to estimate the volume of this object, a milk carton. Clicking on the secondary toolbar for the measurement tool icon, and then clicking on the icon for a ruler, then holding the shaded region, darker region in the middle, pull the ruler down to start to measure the base. By holding the numbers and rotating, we can get a measurement for the width of approximately 4 centimeters. Assuming that the base is a square, we would have measurements for the width and the length 4 by 4. Holding the numbers and rotating the ruler, we can get a measurement for the height, which is approximately 7.5 centimeters. And then we could use our calculator to calculate the volume based on those measurements. 4 by 4 by 7.5 would give us a volume of approximately 120 centimeters cubed. In our second example, we'll use the different functions of the ruler to determine the actual height of the milk carton. So by measurements and using a scale, we can look at a ratio of measurements and determine the actual height. So first of all, moving a ruler once again down to our workspace, we will now resize and rescale that ruler and use 1 centimeter of actual measurement to represent 6 centimeters of actual length. So first of all, clicking on the end of the ruler and resizing it so we have more room on our workspace. And then rescaling our ruler by clicking on the little circle at the bottom right and dragging out so that we have our scale of 1 centimeter measurement to represent 6 centimeters of actual length. So now move that ruler to measure the height of the milk carton. We have that measurement approximately 3.2 centimeters. And so with our scale of 1 centimeter measurement representing 6 centimeters length, or using a ratio 1 to 6, we see now that our measurement of 3.2 centimeters would represent an actual height of 19.2 centimeters. In our last example with the ruler, we can have a discussion in trigonometry around the unit circle and special triangles with a 30-degree, 60-degree, and 90-degree angle. So pulling this tab out, we can look at, for a special angle or a specific angle, is there a relationship between the side lengths of a special triangle when the unit measure is changed? So for the first unit measure, we will use the ruler and rescale it to have the radius 1 centimeter. So pulling a ruler onto the workspace and starting to resize again and rescale using the circle at the bottom right. So that we get our unit of measure for this circle radius to be 1 centimeter in length. So continue to rescale. We now have a measurement for our circle radius 1 centimeter. Rotating the ruler by holding the numbers and rotating for 30 degrees, We can now start to construct our special triangle, drawing in the length of the radius. And then completing our triangle. We can draw the height. And measure that height to be 0.5 centimeters. And completing our triangle so that we have angles 30, 60, and 90. We now have measurements 1 centimeter and a height of 0.5. So for an angle of 30 degrees and a unit measure of 1 centimeter, we find our triangle has a height of 0.5 centimeters. If we were to change that unit of measurement to 4 centimeters, how would that affect our height? So here we rescale our ruler so that that radius of that circle will be 4 centimeters. So here we are rescaling, and now we have a radius or a unit measure of 4 centimeters. Now measuring the height. We see that the triangle now has a height of 2 centimeters. So for a unit measure of 4 centimeters, we find our special triangle has a height of 2 centimeters. And we have an equivalency of the two ratio of sides. Our next session, we'll look at how to use a protractor.